What is Bitcoin Cash? Is it the same as just Bitcoin? And what's the difference between the two? And which is the true Bitcoin? Well, stick around. In this episode of Crypto Whiteboard Tuesday, we'll answer these questions and more. Hi, I'm Nate Martin from 99bitcoins.com, and welcome to Crypto Whiteboard Tuesday, where we take complex cryptocurrency topics, break them down, and translate them into plain English. Before we begin, don't forget to subscribe to the channel and click the bell so you'll immediately get notified when a new video comes out. Today's topic is Bitcoin Cash, also known as BCH. The story of Bitcoin Cash goes much deeper than just the creation of another cryptocurrency. It was actually one of the fiercest tests for Bitcoin's decentralization. So let's get started. A lot of people who are just starting out with Bitcoin or cryptocurrency in general get confused when they see that there's not just one type of Bitcoin. For example, Bitcoin Cash, Bitcoin Gold, and Bitcoin Diamond are all forks of the original Bitcoin. A fork can be described as an alternate version of an original coin. There are two types of forks, soft forks and hard forks. Soft forks are versions that will work well with both the original version and the alternate version of the coin, so as a user you can choose which version to run without a lot of concern. Hard forks, on the other hand, don't play well with the original version. This means that you need to choose whether to update your software to run the alternate version or to stick with the original one. In other words, with hard forks, if the alternative is not accepted by 100% of the users, then a sort of split will occur in the network and a new coin will emerge, one that is similar to the original but not identical. Bitcoin Cash and other Bitcoin versions are actually the results of suggested updates to the Bitcoin protocol that weren't agreed to by everyone. So what happened is that an alternate version of the coin, or hard fork, stemming from the original Bitcoin was created and new coins came into existence. If you want a complete, detailed explanation about forks, make sure to watch our Bitcoin Whiteboard Tuesday Forks video as well. So now we know that Bitcoin Cash is actually a hard fork of Bitcoin, but why was it created? To answer this question, we need to pause for a second and go back a few years to discuss one of the most controversial topics of Bitcoin's code, the block size and scalability issue. Bitcoin transactions don't get confirmed instantly. In order for a transaction to be considered as confirmed, it needs to be included as a part of a block of transactions on the Bitcoin ledger, known as the blockchain. A new block of transactions is added to the blockchain on average about every 10 minutes. Similar to any type of digital data, adding Bitcoin transactions to a block requires storage space, and the maximum capacity for each block of transactions is 1 megabyte. When you consider the average Bitcoin transaction size, you'll find that a block is able to hold about 2,700 transactions. 2,700 transactions every 10 minutes means 4.6 transactions a second, and that's not a lot. Visa, for comparison, can confirm 1,700 transactions per second. Well, this means that when a lot of people want to send Bitcoin, during price rallies for example, transactions get stuck in a very long queue waiting to enter a block and get confirmed. Of course, Bitcoin allows you to pay a higher transaction fee if you want to jump the queue, but this might cause fees to reach ridiculous levels as more and more people try to cut the line with their transactions. This isn't something you want to have happen if you're building Bitcoin to become a global payment method. As a result of this scalability issue, two different camps emerged. The first camp was the Big Blocks camp. This camp was led by Chinese mining giant Bitmain and Roger Ver, an early Bitcoin investor who was involved with a number of startups when Bitcoin was just gaining initial adoption. Big blockers were afraid that Bitcoin's scalability issue would prevent it from becoming what Satoshi Nakamoto, Bitcoin's inventor, initially intended, a peer-to-peer payment system. With such long confirmation times and high fees, people wouldn't use Bitcoin for day-to-day transactions and would instead treat it as a store of value, like gold. The supporters of this camp suggested a very simple solution. Let's increase the block size. If we increase Bitcoin's block size to 8 megabytes, we'll be able to confirm as many as 8 times the number of transactions per second. And this will reduce the existing congestion of the network and in the future will increase the block size as much as needed as Bitcoin achieves further adoption. Opposing them was the small blocks camp. The supporters of this camp rooted for keeping the current 1 megabyte block size while finding solutions for optimizing transaction size and handling in order to enable scaling. One such solution was segregated witness, or SegWit for short. SegWit is an upgrade to the Bitcoin protocol which, among other things, effectively reduces the transaction size by 75%. This means that a 1 megabyte SegWit block can hold the same amount of transactions as what would be a 4 megabyte non-SegWit block. Additionally, small blockers talked about the development of the Lightning Network, a second layer on top of the Bitcoin protocol that allows for instant and feeless transactions. Now, the Lightning Network is a pretty broad topic on its own, so make sure to catch our Lightning Network episode for a detailed explanation on how it works. But why were the small blockers against increasing the block size to begin with? The reason is that small blockers believe that in the long run, this would hurt Bitcoin's decentralization and functionality. And here are some of the arguments to justify their claim. For one, an 8 megabyte or even 32 megabyte block takes more time to travel through the network than a 1 megabyte block. Additionally, once the block reaches a computer on the network, that computer now needs to verify all of the transactions inside that block. If the block is too big, it might not be able to finish verifying all the transactions before the next block arrives within 10 minutes or so. Now, this means the network will start lagging behind new transactions, which can create disputes about the current state of the Bitcoin ledger. On top of that, by not optimizing transactions, you're also not optimizing the size of the blockchain, which already takes up several hundred gigabytes. Forcing computers to verify oversized transactions reduces the number of computers that can store the blockchain on their hard drive and therefore diminishes the network's decentralization. I mean, let's think about it for a second. If only high-end computers that are maintained by a handful of companies can validate transactions on the network, we're basically taking away Bitcoin's basic advantage to have a large amount of participants to make sure no one is breaking the rules. To make it simple to understand, consider this analogy. Imagine a street that's suffering from heavy traffic. Well, the obvious solution would be to increase the number of lanes, effectively the same solution as increasing the block size. But what would you do once the street becomes more popular and even more cars come in? Eventually, there's a limit to how many lanes you can add before running out of land to build it. On the other hand, you could reduce traffic congestion by promoting public transportation routes or carpooling, solutions similar to optimizing the transaction size and how transactions are handled by the network. This heated argument between the two rival camps went on for several years until it climaxed in August of 2017. Back then, Bitcoin was making its first steps over the $1,200 mark, and the network was getting pretty crowded due to an overflow of transactions. As a result, many transactions got delayed, and transaction fees skyrocketed as people were outbidding each other to cut in line and get confirmed faster. The average fee around that time was as high as $37 per transaction. Now, you may be wondering why nobody took action to avoid this situation. Well, in order to answer this question, we need to understand who actually decides anything on the Bitcoin network. You see, Bitcoin is decentralized, and this means there's no one person that decides anything. Participants in the network vote through their actions. Their vote is actually whatever version of the Bitcoin protocol they choose to run on their computer. There are several players in the Bitcoin network. First, there are the miners and mining pool operators. They're the ones in charge of creating blocks and updating the ledger of transactions. And some would argue that they have the ultimate say in what changes are finally accepted to the Bitcoin network. Well, then we have the developers, which are a group of individuals collaborating together to maintain Bitcoin's source code. And some believe that this group has the ultimate power since they're the ones writing the actual code that runs the network. We also have exchanges, which are the gateways for cryptocurrency adoption. Well, they can decide which version of Bitcoin to list under the ticker symbol BTC. Well, they're the ones who have the power of connecting people with the actual coins. Another important group are the wallet providers. They write software that allows users to manage their coins. Additionally, we have the nodes, which are the different computers which run the Bitcoin code and make sure no one is breaking the rules. These nodes are the backbone of the Bitcoin network, and owners of the nodes can decide to only accept transactions that support specific changes. And finally, we have the Bitcoin users, who get to choose which coin to buy, which exchange to use, and which wallet to download. Without even knowing it, they actually have the most power. The coin that users decide to adopt will have the brighter future. A good example for the power of user adoption is the case of Ethereum's hard fork. Back in 2016, after several $1 million were stolen from an Ethereum-based project called the DAO, the Ethereum developers suggested rolling back the Ethereum blockchain and erasing the malicious transaction. Well, this created a heated debate, at the end of which Ethereum forked into two different coins, Ethereum and Ethereum Classic. However, what's known today as Ethereum is actually the altered Ethereum version and not the original one. The reason that this is considered the true Ethereum is because that's the coin most of the users decided to adopt. Miners, exchanges, wallet providers, and even developers all rely on the acceptance of the public to survive. That's why, in the end, the users have the final say. Now you understand why it's so hard to get any change to the Bitcoin protocol approved. You basically need to get all of these groups to agree. Throughout Bitcoin's history, there have been several cases where such agreements were reached, but as the network grew larger, it became harder to reach a consensus. Going back to our story in 2017, the end result of this Mexican standoff between the two camps was that each side did what they initially intended to do, leaving it to users to decide which coin to adopt as the true Bitcoin. On August 1st of 2017, small blockers activated SegWit on the original Bitcoin protocol, while big blockers created Bitcoin Cash, a Bitcoin fork with an 8 megabyte block size. Initially, it was unclear which version of Bitcoin would win, when winning in cryptocurrency terms means having a longer blockchain or ledger of transactions. The more miners a coin has on board means more computational power, hence a longer blockchain and a more robust network. Bitcoin Cash had support from mining giant Bitmain, and as a result, the original Bitcoin's hashing power was cut nearly in half when the fork occurred. However, when the dust settled, it became clear that the original Bitcoin was still standing strong even after the fork. Since the fork, Bitcoin Cash has consistently maintained its space at the top of the cryptocurrency charts. The coin is backed mainly by Roger Ver, a libertarian who allegedly owns around 100,000 Bitcoins, making him one of the first Bitcoin billionaires. Ver also purchased the domain name Bitcoin.com to promote Bitcoin Cash, as opposed to Bitcoin.org, which is the website for the original Bitcoin. Bitcoin Cash is mostly similar to Bitcoin, but with some exceptions. First, its block size is bigger. When it first started out, Bitcoin Cash's block size was capped at 8 megabytes. Later on, the coin went through another update and its block size limit increased to 32 megabytes. In practice, Bitcoin Cash isn't as popular as Bitcoin, and its blocks rarely surpass 1 megabyte of transactions. Second, Bitcoin Cash does not support SegWit or the Lightning Network. And finally, Bitcoin Cash adjusts its mining difficulty for mining new blocks more quickly than the original Bitcoin. I won't go into detail, but it's claimed that miners can actually manipulate this feature to create questionable advantages. While there are additional differences between the two coins, the ones I've mentioned are the ones that are most notable. In November of 2018, Bitcoin Cash went through its own hard fork. This time, the two camps were the original Bitcoin Cash, also known as ABC, and Bitcoin SV, which stands for Satoshi's Vision. Bitcoin ABC's camp was led by Roger Ver and Bitmain. The Bitcoin SV camp was led by Craig Wright, a person who previously claimed to be Satoshi Nakamoto but never supplied ample proof, and Calvin Ayre, the owner of the largest Bitcoin Cash mining pool, CoinGeek. There are two main differences between the two Bitcoin Cash versions. Bitcoin ABC maintained a maximum block size of 32 megabytes, while Bitcoin SV increased its block size to 128 megabytes, with additional increases planned in future updates. Additionally, Bitcoin ABC added smart contract-like functionality into its code, while Bitcoin SV chose to not accept this change. For now, it seems that Bitcoin ABC has become more popular and is considered by most as the true Bitcoin Cash. Before we conclude today's extensive video, I'd like to leave you with some food for thought. Sometimes the obvious solution to a problem isn't necessarily the best one. Low transaction fees are important to the usability of Bitcoin, but not at all costs. And a quick fix often has unforeseen consequences. I mean, just imagine what life would be like if instead of investing in and developing file compression technologies, we would simply have to buy additional hard drives just to save all of our uncompressed documents, photos, videos, and projects to our computers. And how much longer would it take to transmit those files along the internet to our friends, family, colleagues, or clients? Keeping this in mind, it would seem as though optimizing data within small blocks while maintaining decentralization will pay off in the long run. Adding to the block size might prove necessary, but it should be used sparingly. For now, the Bitcoin Cash hard fork saga stands as a testament to the decentralized nature of the Bitcoin network. It demonstrated how unbiased the system is and how no single party can dictate what will happen, even when very powerful interest groups are involved. That's it for today's episode of Crypto Whiteboard Tuesday. Hopefully by now you understand what Bitcoin Cash is, a hard fork of Bitcoin's protocol that created a new coin with a larger block size. You may still have some questions. If so, just leave them in the comments section below. And if you're watching this video on YouTube and enjoy what you've seen, don't forget to hit the like button. Then make sure to subscribe to the channel and click that bell so you'll be notified as soon as we post a new episode. Thanks for watching me here at the whiteboard. For 99bitcoins.com, I'm Nate Martin, and I'll see you in a bit. 32 megabyte block takes more time to travel through the network than 1 megabyte. Can't say 1 megabyte. Are important to the usability of Bitcoin. Now I'm having trouble with usability. It's awesome. Actually, the results of suggested updates to the No. Let's go back to that. Well, that's it for today's episode. Oh, wow, you were so good.